Hello and welcome to our lesson on finding least common denominators for rational expressions. We're going to need this skill in order to add and subtract rational expressions that don't have common denominators. As we discussed in the last topic, we have to have that in order to add and subtract. So what is a common denominator, first of all? Remember that the rules that apply to normal fractions are going to apply to rational expressions. So let's start there. Okay, what is a least common denominator? Like, if I'm trying to add the fractions that I have here, 1/2 and 2/3, what could I use for a common denominator? Well, I have lots of options for just regular old common denominators. Common denominators could be like 12, or let's see, 6, or I don't know, 18, 24. There's all kinds of randomness, and I don't know why I didn't put those in order, but all kinds of numbers I could put on that list. So I could use any of those numbers, and this list could continue for common denominators, because all of those denominators, or all of those numbers, are divisible by both denominators. So both 2 and 3 will divide into 12, or both 2 and 3 will divide into 6, or both 2 and 3 will divide into 18. So a common denominator is a denominator that all other denominators in your expression or your equation, they all divide into evenly. So we need a number that our denominators divide into, and then later it'll be a number and or some variables or polynomials that our denominators will divide into. Now, if you're trying to add, again, let's say 1/2 and 2/3, really any of those common denominators is going to be fine. But when we're dealing with rational expressions, we really want to try to use the least common denominator. And your least common denominator, which we'll abbreviate LCD, or we can also sometimes call it the LCM because it is also the least common multiple. It's going to be the smallest common denominator that your denominators all divide into. And the reason we want to use the smallest when we're dealing with the rational expressions in particular is because we want to have less reducing, okay? When you're reducing normal fractions, the reducing process isn't difficult, especially because we have calculators that do that for us. But the calculator is not going to be able to reduce for us the actual variable portions, and so we want to make our common denominator as small as possible to eliminate the reducing as much as possible, okay? So in this particular case, the 2 and the 3, the least common denominator, the smallest number that they're both going to divide into is 6. So we'd say the least common denominator, or again, we could call it the least common multiple, would be 6. That's the smallest number they both divide into. Okay. Now, if we're, again, not talking about variables, but just numbers, and the number piece will be important when we add the variables in, we can use the calculator to find just that least common multiple. And when I say calculator, I mean, of course, Desmos, and most regular calculators will do this too. They all do it in different ways. But in Desmos, if you wanted to find the least common multiple or least common denominator for a set of numbers like that, you're going to go into functions, you're going to go to miscellaneous, and then you're going to choose LCM, and then you're going to just put your numbers in there separated by commas. So if it was 2 and 3, and even let's say we threw, and you could see 2 and 3, least common multiple 6, but if it was 2 and 3 and, I don't know, 18, then 18 is going to be your least common multiple or least common denominator if you didn't have any variables in there, okay? So if you struggle with that piece, then the calculator is helpful there. Now, how do we do this for rational expressions, okay? For rational expressions, we're going to start by making sure that all of our denominators are factored completely. Make sure they're all factored. That way we can see what components are involved. And then we're going to look at the single terms first. The single terms first. The monomials. Each of our denominators have any single terms. We're going to look at those first. And what we need, let me deviate for a second here. So if we were adding 1/2 and 2/3, right, if these are the two fractions we were dealing with, we said that the least common denominator, least common multiple would be 6, right? So if instead of having just a 2 and a 3, let's say we had a 2x and a 3x squared, how would that affect our common denominator? Well, we would still use the 6 to take care of these coefficients of 2 and 3. But now that we also have an x and an x squared in there, what do we also have to have in our least common denominator? So the 6 still divides by the 2, it still divides by the 3. But in order for it to say divide by an x, okay, I would have to have an x here. So now if I try to divide it by 2, it does divide into 6, and if I try to divide by the x, x does divide into x. So we would be good. But if I wanted to have this be divisible by the 3 and the x squared, well, when I try to divide by 3x squared, the 3 does go in, but x squared doesn't divide into x. This would have to be an x squared here. So now that I've changed that to an x squared, does it mess up the first fraction? So if I make this an x squared, is it still divisible by a 2 and an x? Well, sure. 6 divided by 2 is going to be 3, and then 2 minus 1 means I have x to the first left. So my least common denominator is going to end up being the 6, which took care of our coefficients, and the x squared. Okay? Now, let's say I threw in another fraction here, or let's leave this. Let's say that this was a 4 instead. Well, if this is a 4 and I try to divide by 3x to the 4th, then this would have to be a 4 in order for it to divide in. And again, the 2x would still divide in. So what we're going to be looking for here is sort of the opposite of what we're doing with the greatest common factor. Okay? If we were looking for a greatest common factor, we want the smallest number that divides into our numbers. When it's the least common multiple, we want the smallest number that our numbers divide into. And with the greatest common factor, we take the smallest exponent we see on our variables, and with the least common multiple, we take the largest exponent. So we're going to start by looking at these, what we call single terms, these monomials. And we want the smallest number the coefficients divide into. So in this case, the smallest number 2 and 3 go into is 6, just like if we were finding a common denominator for normal fractions. And then as far as the variables go, we're just going to take any variables and their largest exponents. Okay? So far, if I had 1 and 2x and 2 and 3x to the 4th, my least common denominator would be a 6x to the 4th. Okay? So we look at those single terms, and the LCD is going to have to include the smallest number that the coefficients divide into, as well as any variables and the largest exponents that occur with them. Okay? Now, sometimes our denominators are going to include binomials, right, or trinomials, or polynomials that have more than one term. So what's going to happen with those? Well, let me show you. Okay, let's say that I added an x plus 1 as a factor into this denominator. Okay, if I need my least common denominator to be divisible by this entire denominator, well, when I try to divide it by 3x to the 4th, we're good. But if now I have an x plus 1 there, then I would have to have an x plus 1 in my common denominator as well. And let's say that this denominator had a factor of x plus 2. Well, if I try to divide by 2x and x plus 2, the 2x goes in, but in order for the x plus 2 to go in, it would have to be in that common denominator as well. So as far as binomials or larger polynomials go, we just include one of each. Whatever binomials occur in our denominators, they have to occur in our common denominator. Okay? So the LCD must also include one of each binomial in order for each of our denominators to be divisible. Okay, or divide into. And then the last bullet we're going to save. So for now, I think we have enough to get started. Let's say we wanted to identify the least common denominator for these three denominators. The numerators, I totally just put random numbers up there. They do not affect what we're doing for common denominators, as far as finding the common denominator. So we're ignoring those numerators, just looking for what would a common denominator be, what would the least common denominator be, or least common multiple be for these three. So our least common denominator first is going to be the smallest number that the coefficients, the 3, the 6, and the 1, all divide into. Well, the smallest number 3, 6, and 1 go into is going to be 6, so that takes care of the coefficients. And then for variables, any variables we see have to be here, and we take them with their largest exponents. So 6x to the 5th, just kidding, that's not the biggest. 6x to the 7th. The 7 is the largest exponent that occurs on an x. So our LCD is 6x to the 7th. And again, this just needs to be divisible by all of the denominators that we have there. So if I wanted to check, can we divide it by 3x to the 7th? Yep, 3 goes into 6, x to the 7th goes into x to the 7th. Can we divide it by 6x? Yes. And can we divide it by x to the fifth? We can. So if our common denominator divides by each of our denominators, we're in good shape. We're going to be able to use it eventually to add and subtract. Okay? How about number 2 here? Least common denominator. So we're going to start by looking at our coefficients. Smallest number 4, 12, and 8 go into. And for me, like, this is not so hard, but remember, if you tend to struggle with that type of thing, if you're not so good with the math facts, then just put it into calculator. What's the smallest number? 4, 12, and 8 all go into, and the calculator will tell you that it's 24. So 24 is going to take care of 4, 12, and 8. And now I have x's and y's occurring here, so my common denominator is going to have x's and y's. The question is how many of them. So we take the variables and their largest exponents. So the largest exponent on x is a 3, and the largest exponent on y is a 2. So 24 x cubed y squared would be our least common denominator. Okay? If you're feeling like you can do this, then try out the next one. Otherwise, let's go here. Let's see. Smallest number that 7, 2, and 14 go into. Well, they're all going to divide into 14. And then I need x to the 4th power because that's the largest exponent I see within x. And that's it. Okay? So now, let's look at some larger polynomials with more than one term. So this binomial we're going to consider separately from the single terms that we see here. So we're going to start by looking at our single terms. So looking at our single terms, let's ignore the x plus 1 for a second. Looking at the 3 and the 6x first. The smallest number 3 and 6 go into is 6, and we have an x up there to the 1st power, so 6x will take care of those two terms. And then as far as the binomials go, we just need to include one of each. So if there's an x plus 1 there, there's going to have to be an x plus 1 in the common denominator. And again, we need to make sure that all of our denominators divide in. So if I divide by 3, 3 goes in. Okay, if I try to divide by 6x, it's going to divide in there. If I try to divide by the last one, which is x plus 1, it's going to divide in there. So each of our denominators divides in, which means we have a valid common denominator there, and it happens to be the least common denominator. Okay, similar process here. So we're going to look at these binomials, this binomial and this binomial, separately from our single terms. So least common denominator, again, we're going to look at these single terms first. So looking at the 5x squared and the 10x. The smallest number 5 and 10 go into is 10. And then we have an x to the 1st and an x to the 2nd, so an x to the 2nd. That's going to take care of those single terms. And then binomials, simple, one of each. So if I have an x minus 4 here, I need an x minus 4 here. And if I have an x plus 2 here, I need an x plus 2 here. And that is my least common denominator for those 4 denominators. Okay? Again, if you're feeling like this is something you can handle, then try it out in the next one. So for this least common denominator, we're going to look at these single terms first, the 12x squared and the 18x. And we need the smallest number 12 and 18 go into. Again, if that's tough for you, feel free to rely on your calculator. Let's see, we want 12 and 18, and they're both going to go into 36. So 36, and then we have an x to the 1st and an x squared, so x squared. And then one of each binomial, and we've got an x minus 3 here, which means we need an x minus 3 here. And that's going to be our least common denominator for those denominators. It's a little uncentered. There we go. Okay, so far so good. So now, and I promise we're going to come back to that bullet point. I hope I didn't erase anything. Did I move? Okay, sorry. Sometimes I forget my erases on and I swipe to the next page and I mess stuff up. All right, in the next few examples, what we're going to see is polynomials that can be factored. If we have polynomials that can be factored, we need to factor before we try to establish what pieces need to go in our common denominator. So for example here, the x squared minus 25, that's a difference of squares, right? That's x squared minus 5 squared, so we're going to factor into an x plus 5 and an x minus 5. So then our least common denominator. Well, we don't have any single terms. We have all binomials, and we just need to include one of each. So I see an x plus 5, actually twice, but that's okay. I just need one of each, so x plus 5. And then I also see an x minus 5, so my common denominator is going to have an x minus 5. Okay? And then similarly here, let's see, we can factor this trinomial. So factors of 2 that make 3 are 2 and 1, which means this is going to factor into 1x plus 2 and a 1x plus 1. And so when I go to find my least common denominator, one of each binomial. So I've got an x plus 2 occurring in each of those. All right, let's put one of those in our common denominator. And then I have an x plus 1 occurring here, so I've got to have that in my common denominator as well. Not so bad. Okay, again, feel free to try this out. It's a good place for you to pause and make sure you can handle it. If not, let's see, this is x squared minus 7 squared. So this difference of squares is going to factor into x plus 7 and then x minus 7. And so least common denominator is going to have to include definitely an x plus 7 and also an x minus 7. And there it is. Okay, not so bad. Let's see, more factoring. Here, we're going to take out a GCF of 3x squared, which is going to leave us an x plus 1. And the second denominator, we can take out a GCF of 4x, which leaves us an x plus 1. So now when we go to find our least common denominator, we want to look at the single terms first, which in this case are going to be our GCFs. Okay, the 3x squared and the 4x. So the smallest number 3 and 4 go into is going to be 12. And we got an x squared next to the first, which means I need an x squared with that 12. So that 12x squared takes care of those coefficients in the single terms. And then one of each binomial. So if I have an x plus 1 that occurs in these denominators, then I need an x plus 1 in my common denominator. Okay? Moving right along. We got to factor some more here. So on this guy, 2 times negative 3 would be negative 6. Factors of negative 6 that make negative 1 would be negative 3 and 2. Dividing those by 2 and reducing, we see we're going to factor into 2x minus 3 and then x plus 1. And the second binomial here, the second denominator here has a GCF of 3. So if that comes out, we're left with 2x minus 3. And then I can't do anything with the 9x squared, just going to bring it down so I can look at those all together. So now when I go to find my least common denominator, looking at my single terms first means I need to take care of the 3 and the 9x squared. So the smallest number 3 and 9 go into is 9. And then I also have to include that x squared, and then one of each binomial. So I see some 2x minus 3's up here, which means I need 1 down here. And I see an x plus 1, which means I also need an x plus 1. And there you have it. Okay? Again, one for you to try if you're feeling like this is something you can handle. Get everything factored, and let's figure out what this common denominator is going to be. So factors of 2 that make 3 are 2 and 1. Dividing by 1, we know this is going to factor into 1x plus 2, 1x plus 1. Second denominator has got a GCF of 2x. Factoring that out is going to leave us an x plus 2. And then I can't factor 3x cubed, so I'm just going to bring that down. So least common denominator is going to take into account these singles first. Smallest number 2 and 3 go into is going to be 6. And then between the x to the first and x to the third, I need to keep the x to the third, the larger exponent. And then one of each binomial. So I see these x plus 2's, which means I have to have an x plus 2 here. And I see this, x plus 1, which means I need an x plus 1. And we're good. Okay? Now just to clarify, just to make sure that we're understanding when we're finding this common denominator, remember, this common denominator has to be divisible by each of the denominators above. So if I try to divide this by the first denominator, which is x plus 2 and x plus 1, is it going to divide in? Yes, those will divide in. Not an issue. Okay, let's check the second one. Does 2x times x plus 2 divide in? Yes, x plus 2 divides in, 2 divides into 6, x divides into x to the third. So we are good. And the third one, does 3x cubed divide in? Absolutely. 3 divides into 6, and x cubed divides into x cubed. So we are good. Okay, if you just want to double check, make sure that all of your denominators divide evenly into what you're saying is the common denominator. All right, let's keep moving along here. Let's get everything factored. X squared minus 4 is a difference of squares, x squared and 2 squared. So it's going to factor into our conjugates, x plus 2x minus 2. And I can't do anything with that. And I can't do anything with that. And then here I could take out the GCF of 15, which will leave me an x plus 2. So in my common denominator, singles first. Smallest number that, let's see, 5 and 15 go into is going to be 15. And I'm going to have to keep an x squared with that 15. And then I see some x plus 2's. So I'm going to have an x plus 2. And then if I have an x minus 2, I'm going to have that in my common denominator as well. Okay? It's not horrible. There's only one other little detail that we've got to worry about, and that's going to be occurring in this last problem here. So when we go to factor x squared plus 6x plus 9, the factors of 9 that are going to make 6 are 3 and 3. So this is going to factor into an x plus 3, 1x plus 3, 1x plus 3. And then I can't do anything with these two. So when I go to find my least common denominator, the smallest number that 6 and 3 go into is 6, and I'm going to have to keep the x squared with that. And then because I have an x plus 3 happening up here, then I'm going to have an x plus 3 happening here. Right? Seems like it's the same as all the others. But remember, this denominator has to be divisible by each of our denominators. Does 6 go in? Yes. Does 3x squared go in? 3 goes into 6, x squared goes into x squared? Yes. But our first denominator has an x plus 3 and another x plus 3. So only one of the x plus 3's is going to reduce out, which means in order for this to actually be a common denominator, I would have to have an x plus 3 here twice in order for both of them to reduce. Now, why did I have to have it in here twice when in the other cases I didn't? Okay. For example, in the very previous problem, I see x plus 2 once, twice, 3 times, and I only had to put it once here, and I have it twice here, but I have to put it twice here. Why is this one different? Well, if we look what's happening here, when I go to divide by my first denominator, it's an x plus 2 and an x minus 2. Each of those goes in, no issue. Okay. When I divide by the second denominator, x plus 2, no issue. Okay. When I go to divide by the 5x squared, we're good. If I go to divide by the last denominator, 15 and x plus 2, again, not an issue. Because the x plus 2 only happens once in each denominator. What's different here is not that the x plus 2 is repeating, but it's only happening once in each denominator. Here, the x plus 3 happens twice in one denominator. So if it repeats within one denominator, that's when you're going to have to repeat it in your common denominator. Okay? So that was the last bullet that we left off on the front. If a binomial repeats within one fraction, within one denominator, then you have to repeat it in the common denominator. If you have it repeating, but it's only once in each denominator, then putting it once in the common denominator is going to be sufficient. But if you're not sure, remember, your common denominator has to be divisible by each of your denominators. So you can just check by doing a quick divide. Okay, the only time you'll have to repeat it, though, is if it repeats within one fraction, within one denominator. Okay? Hopefully you've got the skills you need to work on the practice. If you find yourself struggling or needing a little bit of extra help, then just reach out. All right, guys, take care.